Hey, hello there. Today I'm looking at the question 212 word search tool. So the question gives us a 2D board of letters and a list of words. So our task is to find all the word from this list such that we can construct that word by sequentially concatenating the letters on the 2D board. And the letters has to be adjacent with each other. Adjacent means either the horizontal or vertically, so it's a 4-directional move on the board. So also, one last thing is that the letters may not be used twice to form a single word. So that means if we look at the paths inside this 2D grid by moving around to try to form a word, we cannot have a loop. So we cannot have a physical touching loop. So so that's pretty much the question. The example grid looks like this: 4 rows, 4 columns. And we're looking for the existence of these 4 different words inside this board. We can easily verify that we have eat and o's that's highlighted there. So how we go about solve this as a normal human being? If we have this board on a piece of paper, we're just gonna starting with randomly picking a possible starting location. It's character O. So we look at all the words that's starting with O and try to do this matching. We do have one, so we match the O. We just look around, try to match the next character. It's a O, it's a A, so we do find one on the right hand side. So we just match OA, match the prefix OA for the search term, and then we look around, try to find the next letter. So we do find one T, and just keep going until we reach the end of this word. We can declare that we indeed find it. And after that, we can, if we have something that says use O's as the prefix, we can keep going to search for that as well. Otherwise, we'll just go back and see, do we have something that's OATA maybe? If we do have that, we keep the search for that word as well. So it's basically DFS search, and to facilitate this kind of prefix matching to match all the possible candidates with the common prefix, we will use a trie to store these words. So it's conceptually just looking like we're going to start with all the possible locations and try to align the paths, DFS search paths in the grid with the tree paths in the trie. If we find a path matching, we just put that word onto the resulting set or something. It's not clear whether we were going to have multiple ways of forming the same string. Do we have a duplicate or not? I guess it's not. All we care about is whether we can do that word or not. So it's probably a set here. So that's pretty much it. The way to handle this, I guess, is beyond the DFS search and trie. The only thing that requires a little bit of attention is that we don't want to have loops. So we can avoid that by just once we pick the character, we just temporarily flag that as used. And when we do the backtracking part inside the DFS search, so we're done with the search for OATH. There's nothing after that, so we basically uncross H and look for, do we have OATE maybe. So that's the uncross part is done in the backtracking step. So this makes sure that we don't have the same letter being used more than once. So to summarize, this basically backtrack plus the DFS backtrack plus the trie, using the trie. And what we are essentially doing is to align the DFS search paths with the paths inside the trie. So the total runtime for this will be to examine all the possible positions. So that's the size of the 2D grid multiplied by the time it needs to explore the trie. So it's basically n multiplied by n multiplied by the depth of the trie. So that's the time complexity for this problem. The space is basically the size for the trie. It's gonna be linear with respect to the input word size, and also the stack for doing this BFS search is going to be linear with respect to the size of the trie. It's going to grow the deepest possible it can grow is equal to the size of the maximum depth of the trie. So that's the space for this question. yeah, with that we're just gonna try to code up the trie. So we do the trie first, and then let's actually just do the main logic part and then filling out the missing part. So we're gonna initialize a trie, and for all the word we have, we insert that into trie. And then we have an empty set. With this set, we're gonna try all the possible locations on the cell on the board to initialize a backtracking search. The stuff we put on the stack is going to be three things: the row number, the column number, and also the current node we're looking at in the trie. So to initialize things, we have to put the root node of the trie and the row number, column number we are currently looking at. So that's pretty much the like a skeleton for the solution. The remaining work is basically just filling out the missing pieces here, one by one. So I'm gonna try to talk less and concentrate on finishing this as quick as possible. It's a really pretty straightforward once we get the big idea out. The choice of the termination end of word flagging here is a string, and so all the nodes that's not an end of word, it would just be an empty string. That functioning as the Boolean flag as well. If we test whether it's true or not, empty string will be evaluated to false, so it's not an end of word. For the real end of word node in the trie, we'll just directly put the word on there, so that once we reach the end, this is basically the dot word property for this node we're looking at is basically now our candidate for a possible solution, possible word we want. So we can just test that this the node we're looking at does not contain a valid word, non-empty word. If that's the case, we promote that to the crossed. So this is insert the word. We insert the word character by character. If there is a node, not a trie node associated with that character from the previous node, we're just gonna create that using this default factory. And after we've done that, we just keep traversing. And when we reach the end of the word, the very last character node, we turn on this flag, putting the full string of the word onto the node there. So that's the trie, and then it's just to try to code up this backtracking code. So every given time, the first thing first is to check, do we have an end of word on this node? if we do have that, we just put that put that word onto the crossed. So let me move this up. It's not required, but I guess it makes conceptually it's easier because we're gonna put stuff onto the here, or we can put a reference in here, but that's not very. I like things clear, so only put the necessary things as arguments. Okay, so if node.word, then we're just gonna put that onto the crossed. Otherwise, we need to check the character at this row number, column number on the board. Is that a character that a possible next node in the trie? So just think about the initial state. We have a root node here, and we're given the initial search position. The thing we want to see is that do we actually have a word that starts with that character? And it's the same for any subsequent searches. So given row 0, column 0, we want to see, do we have a word that starts with O? So that pings down to going from the root to the path that will lead to the end of this word. So the test is going to be if this character is inside, is a possible next character node for the current node we are looking at. If that's the case, we basically cross this position out. And then we're gonna try to explore from there, try to find the next possible position. Once we've done the exploration, when we do the backtracking, we change this cell value back to its original value. So that's pretty much it. Oh yeah, we need to test whether this is a valid location on the board. So that's 0 is less than equal to r, less than number of rows, and also we have a valid column number. Yeah, that's pretty much this. This is promoting a candidate to the real answer. This is to check, do we have a match? If we do have a match, we're gonna cross that letter out because we use it to match the next character we're looking at. And then starting from there, we're just gonna try to look for the next possible match for the. We're gonna look for the possible match for the next character by looking around in the 4 directions. So just gonna comment a little bit about the time complexity, I guess. I did it in the beginning of the video, I think. So that should be it. Let's just try to run it. It's working. Okay. All right. So it's okay. This question is pretty intuitive. Just the solution comes directly out of looking at the example. We want to do some kind of prefix matching with the word, and only at the end we promote that word to the possible outputs, and then so we use a trie for this, and so on the 2D board part, we're basically gonna try to start the search at every given possible position here. So it's the code is a lot, but the idea is simple. So that's it.